Good afternoon to one and all present over here. It's my fifth lecture on the topic of electronics. Initially, we discuss about the introduction of electronics, and then discuss about the band theory, and then we discuss about the formation of hole, and then we discuss about the uh, how hole and electron recombined. In this way, when we understand the each and every properties of semiconductor, that is electronic properties of semiconductor, now on the basis of Hall effect, we measure different properties of the semiconductor. So we can say the previous lectures describe the electronics and the electronic properties of semiconductor, but today in this lecture, on the basis of Hall effect, I want to explain how Hall effect is applied in electronics in order to measure the different properties of the semiconductor. First of all, we discuss what is Hall effect. Actually, for the given semiconductor crystal, if current is flowing, then perpendicular to this current, if magnetic field is applied, then under the effect of this magnetic field, electric field, a new electric field is produced perpendicular to the applied electric current and perpendicular to the applied magnetic field direction. That is, positive holes are at one part, that is here left side, and here negative carriers on the right side of the crystal, and this phenomena is called Hall effect. It is very clear Hall effect is discovered by Edwin Hall in 1879 by the application of applied electric field and magnetic field for the given semiconductor. A new produced electric field is perpendicular to both applied magnetic field and direction of current. Actually, electrons and holes are very small particles, and on the basis of that particles, semiconductor is defined as either p-type or n-type. So we can say by the use of Hall effect, we can say semiconductor is n-type or semiconductor is p-type. That is, by the slide 4, it is clear Hall effect is used to identify the nature of semiconductor, which is shown in the given slide. That identification of the types of semiconductor is best as the application of Hall effect, and we can say Hall effect is the mathematical analysis by which you understand the type of semiconductor. The visualization of the electric field and applied magnetic field and produced new electric field is shown in the given diagram. Now, on the basis of Hall effect, we can say the magnetic field gives forces on the charge carriers, so it is very clear the holes is going in one side, and it's obvious that negatively charged particle is going in opposite side. And on that basis, we can define the type of semiconductor. Similarly, we can define the mathematical formula. On the basis of mathematical formula, VH is equal to IB upon Q and D, where VH means Hall voltage, that is for the given new electric field. VH is the voltage, where I is the applied current, and B is the applied magnetic field strength. Now, if Q indicates the negatively charged particle and N indicates Q indicates the positively charged particle and N indicates the negatively charged particle per unit volume, and D is the thickness of the material, then we can say the EVV, this is the Lorentz force, and EH, that is the Hall force given by Hall effect. So at the equilibrium condition, Lorentz force must be equal to the Hall effect, or the force given by Hall effect. And on the basis of current density and on the basis of concentration of charges, we derive the relation, that is EH is equal to RH JB, where RH is equal to 1 by NE, that is Hall coefficient is determined by measuring the Hall voltage that measures the Hall field. That is, if thickness is known and EH is known, Hall electric field is known, then we can calculate the Hall voltage. Whereas Lorentz force explain drift velocity that depends upon Ohm's law, and it gives current, and this current depends upon Ohm's law and the permittivity, whereas the current due to the difference in charge concentration is explained by the diffusion current, and it is explained on the basis of Fick's law. So a new knowledge here, that is, not only Ohm's law is sufficient to explain the current inside the conductor, but Fick's law is also required. And we finally summarize the total topic as the application of Hall's law which is mainly focused the forces under Hall effect must be equal to forces given by Lorentz. That is, Hall effect gives complete explanation of the properties of the semiconductor mathematically, like determination or identification of nature of semiconductor, concentration of charge carriers in the semiconductor, magnetic flux density of the semiconductor, and these are the fundamental characteristics which can indirectly measure the other properties of the semiconductor. So we can say the Hall effect is the effect by which the standard calculation of properties of the semiconductor and the relation between electricity and magnetism inside the semiconductor is established by Hall's effect. And finally, I want to say it's my 5th lecture. From day 1 to this lecture, I want to say what is electronics, what is semiconductor, how semiconductor supersede the conductor with the advanced technology, like the external use of temperature, external use of doping, external explanation of other factors, like consumption of energy. It is most useful in today's scenario. Thank you.